Good morning, sir. We are from Group 3 and today we would like to introduce our smart pet collar system. So let's introduce our group member first. So first is Li Minli, Lo Yihui, Tan Pingze, Wu Manchong, and Yao Kaixin in our group. And then now we'll come to the introduction part.
The bond between humans and their pets is often deep, with many individuals consider their pets as part of the family. However, pets might face life-threatening situations due to unforeseen circumstances, leading to various incidents such as pets being trapped inside the vehicle under the hot sun, which can result in their death. One notable case in China involved a woman who ordered a service to transport her golden retriever Siri by air from one place to another in China. However, the change in transportation method from air to land by the logistic company was concealed from the owner, leading to the death of the Siri from heat stroke. Such incidents underscore the urgent need for a innovative solution that can safeguard pets' well-being, particularly during transportation or temporary care scenarios.
Hi, my name is Wu Chong, and now I'm going to talk about the problem statement of our system, the pet collar system, where, as you can see from the slide, the problem statement can be said as the urgent need for technological innovations is to acknowledge the distressing incidents between the pet owners and the pets through some incidents or caused by negligence during the transportations or temporary care through the solutions of smart pet collar, which using of advanced sensors and cloud-based predictive analytics that could prevent potential tragedies and the safety of the pets. And that's all. I'm going to pass it to the next part. Thank you.
Now, our group would like to introduce about the literature review. So in this case, we read three literature. So let's get started. First literature review is about pet care system. So in this pet care system, it actually includes the services like cat feeding notification for the owner, and then the second one is the GPS tracking, and so on. So in this case, they are using the Blink server to do their configuration. Okay, for our project, it's used AWS, but in their case, they are using Blink server. So Blink, what is the difference between the Blink server and AWS? Actually, Blink server is very easy to configure. So it actually very hard to create a smart home system. Okay, so it can fasten the developing time. So actually, it also have a high learnability for those who are not familiar in IoT and system architecture diagram and so on. So it is very good to fasten the developing time. And then second one, it actually also provide a dashboard for the data viewing and monitoring in a glance. But it also have two cons. Okay, so one of the cons is unable to do data prediction. So in Blink server, it only provide like some IoT handle remote, so some IoT remote mobile application. So it is very simple to configure, and it already attached with the mobile apps, but it doesn't provide the services that can do forecast like AWS. So maybe they cannot predict like whether your pet is in the danger mode or not. Yeah. And then the second cons is for developer, we are unable to learn system architecture. So because Blink server is too convenient, so it normally used in their smart home system, which is for those people who are not familiar in IoT. But for those developers who are familiar in IoT, they might not have chance to learn the system architecture. But in AWS, we can learn about the system architecture by placing the suitable components inside, so that we can learn the system architecture.
Good day, sir. I'm Lo Yifei. Now I would like to present about the review of pet smart color system. The advantages of this system is it tracks a variety of health parameters of pets and make analysis of their health risks. So it has real-time alerts for acute changes in vital. It is globally connectivity which links the pets everywhere. It has worldwide GPS tracking also. So the disadvantages of this system is it lacks of accuracy and non-invasiveness. It requires an ongoing subscriptions and GPS capabilities still in development. Thank you.
Hi, my name is Soman Chong, and now I'm going to talk about the free smart pet color system in literature review. Starting from the advantages, the first one will be advanced GPS technology, which involve the help of the LTE cellular service that provide a wide and much more broad distance for the users to acquire the pet locations. The second will be the sleep monitoring features, which is also the standalone features for this system, where the system will be going to use the sleep behaviors to analyze out the pet's vital status. The third will be the durable materials for the pet collar, which they are using waterproof and much more longer battery powers to support the naughty play by the pet. Now I'm going to talk about the disadvantages, starting from the first one, ongoing subscriptions, where the system will need the users to subscribe on the subscriptions so that they are able to unlock all the features, which also include on keeping data on the cloud and to unlock the advanced use of the GPS technology. The second will be the limited cellular service, where the limited can be traced to the rural areas, where some rural areas will not provide much more stronger cellular service, which may affect on the use of the GPS technology. Where the third will be the limited capabilities of health monitoring, where talking about the features of health monitoring in this system, the system does not provide it with a much more advanced or enhanced health monitoring features, where the main core is also the sleep monitoring, which is not so suitable for some users that they needed to take care on the pet's health and other vital status. And that's all for my literature review presentation. Thank you.
Hello, my name is Yao Kai Sing. Now I'm going to present the part future work. First is to develop more advanced sensor technology. Why? It's because with advanced technology sensors, we can collect the data more accurately, which may help during the analytic prediction to be more accurate. Secondly, we are able to integrate the system into intelligent personal assistant. So why? Because every user's phone are having a intelligent personal assistant in it. For example, Siri, Google Assistant, or Alexa. By integrating our system, pet care, pet caller system, into those assistant application, it eases the access for the pet owners, whether asking the assistant, whether asking the personal assistant where their pet is, or the health status about their pets. Thirdly, we can make the product more accessible to the pet owners by making the product that can be easily bought at their reach, as it can collect more data from the pet owners to do. We can use the data to do R&D and testing. By that, we can make the user experience and pet health security much better. Lastly is to replace the is door features to detect animal abuse situation, because during the development using the AWS service, we found out that the is outdoor function is contradict with other features that can be easily replaced by the GPS sensor. We can create a function like geofencing to detect whether the pet is out of the range and out from the house. Therefore, in the future, we can try to develop the features to detect animal abuse by using the live camera feeds into deep learning to identify potential hazard in their pet's point of view environment. And thank you. That's all for me.
Good morning, sir. And then now we will proceed to our user manual.
This is our smart pet collar system architecture diagram, and our product consists of the temperature sensor, oxygen sensor, pulse sensor, GPS module, identity module, and the camera. Other than the camera, all other module or sensor will send the data to IoT core, then IoT core will store the data into the DynamoDB. After that, the event bridge will periodically run the Lambda function to get the hourly fragment from the DynamoDB, then export to the S3 bucket. Then the data inside the S3 bucket will fetch by the AWS forecast to do the prediction, and if the prediction data is considered pet is in danger, then we will send a message through the SNS to the owner device to alert the owner. At the same time, owner also can access the connector through the network gateway to fetch the most recent data which represent the current situation of the pet's data. After that, the image fetched from the camera will pass into the AWS S3 bucket. Then the image will fetch by the recognition to do the label detection, and if the Lambda function detect that the pet is at outdoor, then it will send a message through the SNS to alert the owner.
Now, I would like to introduce about the DynamoDB setup. So first of all, we need to create a table. We need to go to the tab under DynamoDB and go to the tables and then create a table. So we need to fill in the partition key, which is the primary key. So for the sort key is optional. So in our case, we are using sort key. So partition key plus sort key will be our primary key. And then next, we proceed to insert SQL statement. So we select the necessary attributes and then from the topics. Okay, our topic is pet color /plus/data. The plus will fill in by the product ID. Then next, so we can see that when you successfully created a table, it will show a data viewing like this. So, and then by clicking the explore table item, you can see what kind of data are inserted in your table. And then next, we'll come to the setting up the IoT core. So because in our diagram, we are using 4 IoT things. So let's get started. So first of all, let's try to ping this website first. And then when getting replies, it means that the IoT core are able to reach. So, okay. And the next one is, okay, it will automatically lead you to create the things. Okay, the things is actually our sensor. Maybe our temperature sensor. In our case is we are using temperature sensor as our example. And then next, we need to choose our coding platform, which is Python. Okay. In this case, we are using Windows and Python. And then once all the things are done, the policy will be automatically created as well. So next, we can proceed to download the connection kit. And then the connection kit actually include a lot of things like script, certificate, and so on. And so, and then next thing, we need to set up the connection between IoT Core and DynamoDB. So okay, under the tab message routing, so we need to go to the IoT Core there first under the IoT Core, and then there's a tab showing that message routing, and then under the message routing, there will be a rules in the tab. So we click the rules and we'll come to this page. So we need to modify the rules name, okay, followed by the rule description if available. Then next, we need to select attribute again with the same SQL statement. Then next, configure for the rules action. So we need to choose the insert a message into the DynamoDB so that we can insert a message from the IoT Core to DynamoDB. And then fill in the partition key. So we need to fill in our primary key, partition key, and sort key, so on. And then the last one, we need to choose the suitable IAM group. And then after done configuring, then it will also show a review for this. Okay, now I'm going to share about the MQTT test client so that we can see that our IoT Core and DynamoDB is connected. So that maybe your IoT Core can insert a message to DynamoDB. So first of all, let's enter the topic filter, which is pet color /class/data, and then click subscribe. So it will pop up a warning that you cannot publish message to wildcard topics. So wildcard topics means this plus sign exists. So okay, but it doesn't affect our it doesn't affect our topic publish because it only warn for the publish message. So we come to the publish a topic, and then we put the JSON type of our items attribute, and then we key in product key. So we key in for the E at 556. Okay, for demo. So we click publish, and then it here showing that successfully published, but we need to further checking. So we go to the DynamoDB, check it. So go to the DynamoDB table, and then this is the table, explore table item. Okay, so we can see that the item here already created here. So this is table we just created. It will appear here. Then this is all for the IoT Core and DynamoDB.
So to connect the DynamoDB with AWS Forecast, first we need to create the S3 bucket. To create S3 bucket, first we go to AWS console search bar, search for S3 bucket, then click the create bucket. After that, you need to do the naming, then scroll to the bottom and click create bucket. After that, we will need to create the Lambda function. The purpose of Lambda function is to convert the data from DynamoDB to S3 bucket. So same as just now, go to AWS console, search for Lambda, then click the create function. After that, select the author from scratch and do the naming. And for my case, I select for Python. You can select other language as well, and scroll to the bottom, click the create function button. To let it periodically run the function, you need to add the trigger, and under the dashboard data processing session, select for event bridge. After that, you can select existing rule if you already create a rules beforehand, but in my case, I need to create a new rules and do the naming. And for the schedule expression, I write for break 1 hour because I need it to export the data for every hour. After that, scroll to the bottom, you'll find a code tab, and then you can insert your code into it. And after that, you remember to click the Save button under the File tab, then click the Deploy. To test your function, you can click this test button. Then inside you'll find an info button. Then click it to run your function. After that, we need to modify the permission for the Lambda function so that it can access to DynamoDB and S3 bucket. So in the IAM row, we can find a row with the same Lambda function name. And under that, we click the add permission and create inline policy. You can select attach policy if you already create the access policy for DynamoDB and S3 bucket. Inside the inline policy, create inline policy page. I select for DynamoDB service, then enable the necessary permission. After that, scroll down, you'll see a resource section, which I need to select specific for the table and click ARNs, add ARNs. Inside there, you need to type in the region ID and your table name. This is the preview of it. You can click next to do the naming for the policy and create policy. Same goes to the policy for S3 bucket. Create another inline policy. Service, choose S3 bucket and then enable necessary permission. Under the resource tab, select specific and add ARNs. Enter your bucket name, and in my case, I select any object inside the bucket and then add ARNs. If this is the preview of it, then you can click next and do the naming, then create policy for S3 policy. Finally, we can create our Amazon forecast. Same as just now, go to the AWS console search bar, search for forecast, then create the success group. After that, it will require you to do the naming, then select the custom for forecast domain. Then it will require you to create a time series data. Same as just now, do the naming, then set the time interval to 1 minute because the time interval for each record in DynamoDB is 1 minute. So we set for 1 minute. After that, please ensure your dataset column is same as this schema builder. After that, for the dataset import details, do the naming, then select for CSV file, browse for the S3 bucket. Inside there, you are required to select a file or folder that contain the time series data. After that, for the IAM row, click create a new row. You can use existing row if there's a selection for it. Then select a specific row, specific S3 bucket, then click the start. While waiting for the time series data to being import, you can continue for the metadata and related time series data, which is optional. But if you want to import it, it will look something like this, and you are required to do the naming and add the attribute so that it match for your data column. Then under the import details, to the naming and select for CSV file. Then inside the browse S3 bucket menu, select for the file or folder that have the metadata. Then same as just now for the IAM row, this time we can straight use the existing row that we create just now for the time related series data. Time series data. And for the related related time series data, do the naming, and set the interval as same as the time series data just now, which is the 1 minute. Then add the attribute for the schema so that it match our data column. And under the import details, do the naming, select for CSV. Under the browse S3 menu, select the file or folder that contain the related time series data. After that, use the existing row for the time series data. Then we can wait for the dataset being done importing, and after that, after the dataset are done importing, we are required to click this start button when it lights up. You can click on the view dataset to view the progress of the dataset. After you click the start button for the predictor, you are required to do the naming for the predictor. Then for the forecast frequency, set to 1 minute, which is same as the time series data just now. And for the forecast horizon, we set for 59, means we are require it to forecast data at the next 59 minutes. And for the false quantiles, I remain for it. You can edit it. For the optimization metrics, we choose for average WQL. Then we enable the explainability and predictor monitoring. After that, we click the create. There is one tips on here. If you are a free tier account and you doesn't want it to cost any money, you can disable this predictor monitoring. This predictor monitoring will keep retraining the predictor after you done for the first training. This predictor monitoring will keep recurring the training hours until it require you to cost money. After click the predictor start button, you are required to name the predictor, then set the forecast frequency to 1 minute, which is same as the time series data. For the forecast horizon, set for 59 minutes, means it is required to forecast the data for next 59 minutes. And for the forecast quantile, I remain the default value. And under the predictor configuration, select average WQL for optimization metrics, and then enable the explainability and predictor monitoring. After that, click the create button. And after that, you are required to wait for a while to let the predictor to done training. You can click the view predictor to view the progress of the predictor. After the forecast generation start button light up, you can click on it and do the forecast. So you are required first do the naming, then select the predictor. And for the forecast quantile, which is optional, but I insert the value same as the predictor just now. Then after click the start button under this page, you are required to need to wait for the result to come out. After the result is done, you can go in, click on the forecast name to view the detail, and under the export tab, you can click the create forecast export to export the data. And first, we are required to do the naming, then select create a new row for this so that it is able to access the S3 bucket. So specific S3 bucket and enter the bucket name. After that, select the file type to CSV file, then browse the S3 bucket and select the destination. Waiting while then after that you need to wait for the result again, and after it's done you can go to a export location and select for the CSV file and click on download for further action. That's all for me.
Hello, my name is Yao Kai Sing, and now I'm going to present the camera recognition for the AWS service. First, camera will upload every 5 minutes of the frame to the S3 bucket, and the S3 bucket will send the image to the AWS recognition by calling the API at Lambda function. So when the Lambda will auto detect when there is a S3 bucket image is being uploaded, then after the call of the API, it will send the results to the SNS. Okay, then here, first we have to create a bucket. Then I already create a bucket, so here's the bucket, and there are some image right here. So if you choose to upload the picture, and this is the picture. Okay, so let's upload it, and let's take a quick look. Okay, so this is a picture of the POV at the pet collar camera. So let's come to the Lambda function, and this is our function. We check outdoors. First is to set the S3 bucket auto trigger. Here is show that the event listening, the object is being created by the S3 user. So once there is a picture being uploaded to the S3 bucket, it will trigger this Lambda function. First, we have to make it the client. Then this is the function. Basically, it will call the Amazon recognition API and send the image for detection. Then it will return the response, and this is the response we can detect from the label, and we can determine from this code whether our pet is indoor or outdoors. And this is the Lambda handler. Basically, it can extract the key and the bucket name that we just added at the trigger, and dynamically request for the new image being uploaded. So we don't have to code it here manually. So by putting the bucket name and the key from the event listener, we can call the API and print whether our pet is indoor or outdoors. Then after that, we send the message to the SNS topic. This is the SNS topic ARN. We got it from here. We use the ARN here and paste it here and send it the message and then publish it. Now, like we just uploaded the picture like 2 minutes ago, the Lambda function has already been executed behind the scene. So let's come to the email. So yeah, 2 minutes ago, it says your pet is currently indoors. So the pictures that it didn't detect any outdoor features.
I'm Yue. Now I would like to demo about Amazon SNS. I use the Lambda function to get the data from S3 buckets and map an alert message to the users when the pet is in danger. So now I would like to show how to set up all of them. Firstly, we search the SNS in the AWS console. So now click the topic on the side menu. So we have created a topic called danger alerts. Then we have add and subscriptions. We can send the message to the email. Okay, now we need to create the Lambda function. Okay, so the danger alert message has been created. For the functions, here's the functions to get the data from the S3 bucket and send to the email. So the bucket name is pack caller test data bucket, and the file name is called pack caller modData.csv. For this, the file names file looks like get the topic URLs from the SNS topic, which is the danger alerts, and then the alert message will be sent if the pet is in danger. So we will use the timestamp to track whether the pet is in danger. So I will use two timestamps, which one is the pet is not in danger, and one is the pet is in danger. So I use this timestamp first to check whether the pet is in danger or not. But in here it's not right. So I use this timestamp. So this timestamp is used. I copy here and I test the event. So the pet is not in danger, so the alert message will not be sent. So now we use the danger state is equal to true with the timestamp is this is the timestamp. And now we test it. Okay, it says that then your pet is in danger and alert message has been sent to your email. So we go to check our emails. Yeah, here is notification. Your pet is in danger, and also the level is too low. Thank you. That's all from me.
And now I'm going to talk about the cognitive part in this assignment. Starting here, go to the console to search for cognitive service. Then you will see that there are two pools that you needed to create. One is the user pools and one is the identity pools. After you have created for each of them, navigate inside the user pools, you will see that there is already a user created with the status confirmed and the email is verified. Now, let's delete the users, enable the users, and create again. Before that, navigate to each of the features here for the cognitor to work. Then let's create the users. Let's use out the app clients with the hosted UI support provided by the cognitor. Click sign up to create a test user. Same personal Gmail, and the password must be fulfilled with the video connection and click sign up. Before you confirm the account, a verification code will be sent for the cognitor to confirm about the users. So there is already a user created. So now we need to confirm the status. So let's move back to the Gmail, and you will find out that there is a new code, and by using this code to yes, you have been signed up and created and confirmed by the Cognito service. So let's log in back of. So yes, you have been logged in back to the Cognito service, and that is all for the Cognito service. And I'm going to pass it to my next friend. We'll be talking about the SNS service. That's all from me. Thank you.